This short video, I'll share and explain this interactive visualization of the Cayley graphs of some groups. Okay. For those in the know, these will be thought of as subgroups of the symmetric groups Sn. But for those not in the know, do not worry about the sentence I just said. Let us start with the numbers 1, 2, 3, 4 listed in increasing order. Okay, so here I have a node labeled the list 1, 2, 3, 4. I now introduce three rules, okay, three operations, the red, the blue, and the green operations. Here, the red is parentheses 1, 2, which means swap 1 and 2. For example, if I start at the list 1, 2, 3, 4, and I apply the red operation, in other words, I walk along this red edge, then I swap 2 and 1 to end up with the list 2, 1, 3, 4. Okay. Green will swap 3 and 4, and blue will swap 1 and 3. So you see here 1, 2, 3, 4 as a list. If I walk along, let's say, the green edge, I end up at the node 1, 2, 4, 3. Okay. Of course, at that node, I can walk along now the blue edge, which remember swaps 1 and 3, to bring myself to 3, 2, 4, 1. Okay. A natural question, given this starting list 1, 2, 3, 4, and these three rules, is what are all the possible lists that I can reach? And the picture you see here that I am moving around precisely answers that question. Okay. This is an example of a Cayley graph, where the nodes are lists of numbers, and the action of the group, okay, is these arrows that you see. So, for example, all of these arrows correspond with actions. The blue action is everybody start at your vertex, okay, and move one step in the blue direction. Okay, so 1, 2, 3, 4 will move over here. 4, 2, 1, 3 will move over here. Okay, so you can imagine having one person stand at each node, and when you say apply the blue action, okay, that is just everybody walking along their blue edge. Okay, and the construction of this graph is so that indeed at every vertex there is exactly one blue edge coming out. Okay. The point of the video is just to introduce this sort of visualizer. I have other groups, okay, so the one you just saw was S4. That is the result of having these three generators, okay, these red, blue, and green operations, starting with the starting node 1, 2, 3, 4, and applying these operations. What are all the possible lists you get? In other words, what are all the possible sort of paths I can be walking on this Cayley graph? Okay. I also have this A5. You see here that the structure is evolving by itself. Okay, brings along the edges that sort of pull everything into shape. It is in general quite difficult to predict beforehand what shape you get. So here, the resulting structure is more complicated. This is a group called A5, and here we have generators red, blue, and green, and that gives us a total of now 60 nodes. Okay, 60 nodes, starting with 1, 2, 3, 4, 5. Okay. I also have A5, okay, the same group, A5, same 60 nodes. Okay, you will look at all the lists of numbers, and you will see that they're exactly the same lists as appeared before. But here we only have two generators. Okay. Also, various dragging motions that you can perform, and also you can do more jiggling or control sort of the powers of the springs in this animation. Okay. You can also increase the tensions of each color. So, for example, here I'm increasing the red, and here I'm increasing the blue. Okay, and so that does give different shapes. Okay, so you can play around with that. The link is just here. Okay, a lot of A5s. Okay, and they all look slightly different. There are many choices of generators, but the thing to keep in mind is the group. We should think of the group as, okay, there are multiple ways to think of the group. we can think of a group as both nouns and verbs, okay? And the nouns in this case are exactly the nodes, okay? So there are 60 nodes. Those are the nouns of the group, and they are the same in all these visualizations of A5, okay? So from the noun point of view, all these nodes are the same, and so they all are A5, okay? From the verb point of view, that references these paths. Okay, so starting with the list 1, 2, 3, 4, 5, we can get to every other list by applying some of these operations. Okay, and that sort of movement, okay, for example, the movement of first do red and then do blue and then do red again, okay, that is an action, that is a verb you can do on this set of nouns. Okay, so each person on each noun receives this verb to walk the red and then the blue and then the red again, and ends up at another noun. Okay, so those are two different ways we can think of a group. Let me explain in a bit more detail by drawing. So we start with the starting list 1, 2, 3, 4, and suppose I'm going to focus on this other list 1, 3, 2, 4. Okay, as I mentioned before, these are both nouns, okay, of the group S4. This is the first group that I showed you. But this noun 1, 3, 2, 4 can also be thought of as a verb, okay, which I will write as this 1, 3, 2, 4. Underneath just 1, 2, 3, 4. Okay, and this will be read as a permutation. Okay, or in other words, a function from the set 1, 2, 3, 4 to the set 1, 2, 3, 4 that is invertible. Okay, every element over here goes to exactly one element over here, and there is no sort of doubling up, and every element is hit. Okay, this is called a bijective function. I will explain how we read this from this notation. This notation tells us that 1 will map to 1, 2 will map to 3, 3 will map to 2, and 4 will map to 4. Okay, so it's the function that we can draw as this. Okay, so that is a bijection, also known as a permutation. This verb, okay, acts on this starting list by turning it into this other list that I have. Okay, but if we look at the diagram, okay, so please scroll back into the video, we see that we can reach the list 1, 3, 2, 4 from the list 1, 2, 3, 4 by, for example, doing first blue, okay, then red, then blue. Yes, unfortunately, I'm following the function convention of composition going right to left. Okay. Also, we can see from the picture that the operation red, then blue, then red, produces the same thing. Okay. So these sort of actions are the same, or verbs are the same. Okay. So this permutation, by looking at the diagram, corresponds with different sort of paths we can walk on the Cayley graph. Okay, these are paths we can walk on the Cayley graph. And those paths are things that can be walked by every single person standing at every node. Okay, so the way we interpret this is this noun corresponds with the verb that now applies to everybody on the Cayley graph of first walk the blue edge, and then walk the red edge, and then walk the blue edge. Okay, so hopefully you see in your mind's eye many people standing at each node, walking along the sort of edges prescribed by this recipe. Okay, and that's the verb that is acting upon these nouns. So we should think about a group in two ways. We should think about it as a noun, as a bunch of nouns, and also as a bunch of verbs. Okay, and both are very easy to visualize using the Cayley graph. Let me finish with one example. Okay, the main point of the video was to introduce the interactive visualizer. Okay, I just wanted to give everyone a chance to play around with it, but I want to finish with this example this point I was making about nouns and verbs, and them being two different ways of seeing one group. Okay, so we have the integers. Okay, all of the ticks on this number line are nouns. Okay, 0 is a noun, 1 is a noun, and so forth. But we can also think about them as verbs. Okay, so each number here, for example, the noun 1 corresponds with the verb of shift right by 1. Okay, so here is this visualized. Okay, so I have 0, okay, and I'm going to move this black number line to the right by 1 unit. Okay, so that is what that action looks like. I move the point 0, the black point 0, to the gray point 1. Okay, so that is the action, the verb corresponding with the noun 1. Okay, the noun -1 also has a action of shifting left. Okay, so I move this whole number line to the left. Okay, and that is the correspondence of a number with its additive action or verb. Okay, we can also do multiplication. The way we do that is we keep 0 fixed and we move now 1. Okay, so I have the 0 fixed, and I'm going to expand the number line by moving the black number 1 to the gray number 2, for instance. This is the multiplicative verb of multiply by 2. So the noun 2 corresponds with this verb of expand by a factor of 2. Okay, and the same picture holds, for example, in the complex numbers. Okay, so in the complex numbers, we have this same sort of picture. We can move to the right by 1 unit. Okay, that is the additive verb corresponding with the noun 1. Okay, we can move up by 1 unit. That is the additive verb corresponding with the noun I, as so. And we can also stretch or expand or dilate, or in this case, rotate. Okay, so here again, I keep 0 fixed, and I expand 1, the black 1, to the number 2, to the gray number 2. Okay, that is moving 1 to 2, and so that is the multiplicative verb corresponding with the number or noun 2. Okay, and of course, I can move the noun 1, black 1, to gray I, and that will be the multiplicative verb of the noun I. Okay, and that corresponds with a rotation by 90 degrees. Okay, so hopefully with this example of complex numbers, you understand my point of how we can think of nouns as also verbs sometimes. For example, in a situation of a group. Okay,